Okay, fifth years, just wanted to run through a quick discussion on the graph drawing. So I'd asked you to use the online simulator for two of the mandatory experiments yesterday. I hope that went well for you. A really good resource to use, especially in the circumstances that we're in. So I would urge you to have a look at that as often as possible, and you could even use that for revision to look back over the mandatory experiments that we've done before. So the one that I've done for you here, and you can see it on the screen, is the first mandatory experiment. So this is for ordinary and higher level. I just did this one because it's for all students. Higher level students would be expected to do the other one, where we talk about fundamental frequency versus tension, or with tension on the string compared to length, which is the one that we're looking at now. So I used the simulator that you guys had used, and the data that I got is at the very top there. So that's the table that I drew out. First part, draw my table, put in my units, and record all of my results. Nice and simple. So I've got my frequencies on the left in hertz, I've got my lengths in meters on the right. Okay, then the question, well, the mandatory experiment in this case is supposed to be its frequency versus 1 over length. Okay, so what I have to do then is to change my length values to 1 over length. Okay, so you can see I've put it in at the unit. The bottom table, or the second table here, is 1 over L, and it's meters to the power of -1, or 1 over the meter. So what I've done is I've copied down my frequencies as I had: 17, 18, 19, 20, 22, 23, nice and straightforward. And what I had done is that I just did 1 divided by 0.92, and that gave me the first one, 1 divided by 0.88. Okay, so you can see what's happening. As the frequency increases, the 1 over L value increases also. If we look at it the opposite way around, as the length of the string decreases, the frequency increases. I could tie that back to what we did on simple harmonic motion when we did the ruler against the desk, if you recall. If you can hear it, we can hit the ruler against the desk, and if I shorten the length of the ruler, I get a higher frequency. So the shorter the string, the higher the frequency. Same way as if you are using a guitar and you put your fingers on the fret of the guitar, and it will higher the note or increase the frequency or the pitch. Same way as if you touch on a violin or any kind of stringed instrument, you can do the same thing. So I've got my frequency and I've got my 1 over L values. I know that looks like a U, but it's an L, believe me. Okay, so we've got our frequency and we've got our 1 over L values, and then we're going to use that to draw our graph. Nice and straightforward. So I've put frequency on the x-axis. I want that way because they're the ones with the whole numbers, and I think it's a bit easier to do whole numbers on the x-axis and then use the rest. So top tips: first and foremost, give yourself loads and loads of space. Secondly, use graph paper, of course. Thirdly, I want you guys to make sure that we space our units out evenly on the graph, and you gotta label your axes. Okay, so you can see I've named the axis, I've put the unit on the x-axis, the horizontal axis, and the vertical axis, the y-axis. I've got 1 over L, meters to the -1 on my y-axis, and I've got frequency in hertz on my x-axis. So I can see my range of frequency based on my table of data is going from 17 to 23. So I need to get 17 to 23 in there, and I want to make sure that it all fits in. Now I've gone from 0 to 25 because I know it all fits in there. Nice and simple. So I can go up in fives, and again, because I've got graph paper and because the number isn't too big, I'm able to use each box for 1 hertz. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Same idea on the y-axis. I know I need to go from 1.09 to 1.43. Now I've gone up in 0.5, so you can go 0.5, 1, 1.5, 2. I've set it out nice and simple, and again, 5 boxes, 5 boxes, 5 boxes, 5 boxes. So that's the way I've set it up. You can see all my data is kind of clumped or cluttered in the top right hand corner. That's because I'm not using any of the any of the data near to the origin, because my data only starts at 17 hertz, so I'm not using any from 0 to 15. And the same, I'm only starting at 1.09 on the y-axis, so I'm not using anything from the origin up to 1, okay, on the y-axis. So you can see the data points are there. That's fine. I've plotted them nice and simple. You can see I've put simple dot, little circle around it, just to make sure that we're clear and we're accurate in exactly where the point is being drawn. And then finally, I've put in my line of best fit. Okay, now the line of best fit, you can see we're looking for a straight line through the origin to verify that the frequency is proportional to 1 over length. That shows that, and that's what the experiment is all about. So as I increase as I increase the frequency, the length of the string decreases, or the other way around, I suppose. As I shorten the length, I increase my frequency, or as I lengthen the length of the string, make it longer, the frequency will decrease. So that's all it's done there. Now my line of best fit, as I was just mentioning, is important to show that it's not a line from your last data point to the origin. Okay, it's not just line them two up and straight line down there. It's supposed to be the line that goes through as many as the points as possible, or it gets to the center of all your data points as best as you can. Now I tried to do that as well as I could. You could alternatively maybe make it a little bit different, but I'm happy with where I've put it. I feel that it's hit 5 of the data points pretty well, and it's very close to the center point of the 5 of those. So it's only the 5th data point there, which is the 22 hertz point, 22 and 1.37. That's the only one that's kind of not on the best fit line, so I'm pretty happy with my result. I can also show you I've done it on Excel, or just to make sure, on Google Sheets I should say, just to make sure that it's nice and clear. Now again, from 0 up to 15 you can see is a straight line. I've put 0, 0 in as my origin. You can see that in the top left hand corner of the data. Okay, I've put the origin into the data just so it will give me a line from 0, 0 upwards. And you can see that it's not perfect. There's a little bit of a wave on there, but it's that's what experimentation is all about, and that's from a simulator, never mind if you're doing it in real life. Okay, so we can see that that's what we should get. Now I'm not gonna do it for the next experiment. I think you should be able to get the two of them together yourself. All right, thank you very much.